Friends, welcome to class. Today we'll discuss about pair of linear equation in two variables. Before we get into linear equation in two variables, let us first understand the difference between algebraic expression and equation. An algebraic expression is a combination of constants and variables connected by four fundamental arithmetic operations, either plus or minus or into or division. Whereas an equation is an algebraic expression with equal to sign. Without this sign, the given polynomial is an algebraic expression only. Let's understand through an example. For example, 5y plus 3 equals to 0 is an equation. But if you remove the equal to sign, 5y plus 3 is an algebraic expression. Linear equation in one variable. An equation which involves only one variable with highest power 1 is called linear equation in one variable. For example, 3x minus 18 equals to 0, 2y plus 5 equals to 7y minus 10, zy4 plus 2 equals to z minus 6. See, in all these cases, in the first example, there are two terms, 3x and 18. The variable involved is x and the power of x is 1. In the second example, there are two terms on the left hand side of equal to sign and two terms on the right hand side of the equal to sign. The variable involved is y and the power of y on both the sides of equal to sign is 1. In the third example, there are two terms each on either side of the equal to sign, but the highest power of the variable z is 1. So these all are the examples of linear equation in one variable. A linear equation in one variable is always of the form ax plus b equals to 0, where a cannot be equals to 0. In the given form, a and b are the constant and x is variable and the power of x is always 1. Linear equation in two variables. A linear equation in two variables is represented in the following form: ax plus by plus c equals to 0, where a cannot be equals to 0 and b cannot be equals to 0. For example, x plus 9y equals to y plus 10, 8k plus 11p equals to 4, 7x minus y equals to 15x. See here in all these examples, the first example contains two variables x and y, second example contains two variables k and p, third example contains two variables x and y, but the highest power of all the variables is 1. So these are the examples of linear equation in two variables. Let's see the solution of linear equation. The value of the variable which satisfies the given linear equation is called solution or root of the given equation. For example, the root of the equation 2y plus 5 equals to 7y minus 10 is 3. Let's check it. Justification: when y equals to 3, left hand side is 2y plus 5, that means 2 into 3 plus 5, which is equals to 11, and right hand side equals to 7y minus 10, or 7 into 3 minus 10 equals to 11. So left hand side equal to right hand side, so you can say 3 is the root of the given equation. Likewise, let's see another example. The root of the equation 8k plus 11p equals to 4 are minus 5 and 4. That means for k equals to minus 5 and p equals to 4, the given equation it gets justified. Let's see the justification. When k equal to minus 5 and p equals to 4, left hand side is 8k plus 11p, which is nothing but 8 into minus 5 plus 11 into minus 4, or it is minus 40 plus 44, which is equals to 4. And right hand side is already 4. So for the roots minus 5 and 4, the given equation gets justified. So we can say these are the roots of the given equation. Now, pair of linear equation in two variables. Two linear equation in the same two variables, let's say x and y, are called pair of linear equation in two variables. The general form of Linear equation in two variables is a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0, where a1, a2, b1, b2, c1, c2 are the real numbers, and a1 square plus b1 square cannot be equals to 0, a2 square plus b2 square cannot be equals to 0. The pair of linear equation in two variables is also known as the system of linear equation in two variables. Solution of pair of linear equation in two variables. Any pair of values of x and y which satisfy both the equation a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0 is called the solution or root of the given pair of linear equation. A pair of linear equation in two variables can be solved by the following two methods. These are graphical method and algebraic method. Again, the algebraic method further divided into three parts. They are substitution method, cross multiplication method, and elimination method. Friends, we'll discuss the graphical method later on. First, we'll discuss in detail about this algebraic method. But before we get into this algebraic method, let's see the solutions, number of solutions, and consistency of the pair of linear equations. The number of solutions and consistency corresponding to linear equation a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0 are as follows. That is, let's find the ratios or the relation between the constants. The table says if a1 by a2 equals to b1 by b2, that means the pair of linear equation has exactly one solution or unique solution, and the system is consistent. If a1 by a2 equals to b1 by b2 equals to c1 by c2, then the pair of linear equation has infinitely many solutions and the system is consistent. But if a1 by a2 equals to b1 by b2 and it is not equals to c1 by c2, then the pair of linear equation has no solution and the system is inconsistent. Let's see some example. So that the following pair of linear equation is inconsistent. 4x minus 5y minus 12 equals to 0, 10y plus 20 equals to 8x. So the given pair of linear equation is 4x minus 5y minus 12 equals to 0 and 10y plus 20 equals to 8x. That means we can write it as 4x minus 5y minus 12 equals to 0 and minus 8x plus 10y plus 20 equals to 0. So on comparing with the standard equation, a standard form linear equation, we get a1 equals to 4, a2 equals to minus 8, b1 equals to minus 5, b2 equals to 10, c1 equals to minus 12, c2 equals to 20. So a1 by 8 equals to 4 by minus 8, which is equals to minus 1 by 2, b1 by b2 equals to minus 5 by 10, which is equal to minus 1 by 2, and c1 by c2 equals to minus 12 by 20, which is equal to minus 3 by 5. So a1 by a2 equals to b1 by b2, but it is not equals to c1 by c2. Thus, the given pair of linear equation is inconsistent. Let's see another example. Find the value of k for which the system of equation kx minus 5y equals to 2 and 6x plus 2y equals to 7 has no solution. So the given pair of linear equation is kx minus 5y minus 2 equals to 0 and 6x plus 2y minus 7 equals to 0. On comparing both the equation with the standard form of linear equations, we get a1 equals to k, a2 equals to 6, b1 equals to minus 5, b2 equals to 2, c1 equals to minus 2, c2 equals to minus 7. So for the given linear pair of equation, to have no solution, it must satisfy the following relation. That means a1 by a2 equals to b1 by b2, but not equals to c1 by c2. So k by 6 equals to minus 5 by 2, but it should not be equals to minus 2 by 7, or we can write k by 6 equals to minus 5 by 2, or k equals to minus 5 into 6 by 2 divided by 2, which is equals to minus 15. Thus, for k equals to minus 15, the given pair of linear equation has no solution. Let's see some more examples. Find the value of p and q for which the following system of equation has infinitely many solutions. It is 2p minus 1 whole into x plus 3y equals to 5, and 3x plus q minus 1 whole into y equals to 2. So the given pair of linear equation is 2p minus 1 whole into x plus 3y minus 5 equals to 0, and 3x plus q minus 1 whole into y minus 2 equals to 0. So on comparing with the standard form of linear equation, we get a1 equals to 2p minus 1, a2 equals to 3, b1 equals to 3, b2 equals to q minus 1, c1 equals to minus 5, and c2 equals to minus 2. The given pair of linear equation to have infinitely many solutions, it must satisfy the following relation. That means a1 by a2 equals to b1 by b2 equals to c1 by c2. Let's put the values. So it should be equals to 2p minus 1 whole divided by 3 equals to 3 by q minus 1, which is equals to minus 5 by minus 2. So we can write it as 2p minus 1 whole divided by 3 equals to 5 by 2, and 3 by q minus 1 equals to 5 by 2. From solving, we can write it as 2 into 2p minus 1 equals to 5 into 3, and likewise in the second factor it is 5 into q minus 1 into 3 into 2, or 4p minus 2 equals to 15, and 5q minus 5 equals to 6, or p equals to 17 by 4 and q equals to 11 by 5. So the required values of p and q are 17 by 4 and 11 by 5 respectively. Let's see another example. Find the value of k for which the following system equation has unique solution, and the pair of linear equations are kx plus 2y equals to 4 and 8x plus ky equals to 11. So the given pair of linear equation is kx plus 2y minus 4 equals to 0 and 8x plus ky minus 11 equals to 0. So we have a1 equals to k, a2 equals to 8, b1 equals to 2, b2 equals to k, c1 equals to minus 4, and c2 equals to minus 11. Now, a pair of linear equation will have unique solution if a1 by a2 equals to b1 by b2. So putting the values, we get k by 8 equals to 2 by k, or it is k square equals to 16, or k equal to plus or minus 4. Thus, for k equals to plus 4 or minus 4, the given pair of linear equation has unique solution. Friends, here we saw a few examples. We'll discuss the details of the methods, substitution method, cross multiplication method, and elimination method in details in next class. This one for today's class. Thank you.